Never trust a final transmission headline in space unless you're ready for what the data actually says. Subscribe, because 3I, Atlas, didn't speak like a movie. It did something colder. Tonight, we're going to follow 3I. Atlas from first detection to the last clean set of data we can realistically squeeze out of it, and why that last signal is being called a warning. It starts the way most real space stories start. Quiet. Boring, even. A tiny dot where there should be nothing. Not a glowing spaceship, not a fireball, just a faint, moving point caught by a system that does one job all day, every day. Look for things that might surprise us. That system is Atlas Asteroid Terrestrial-impact Last Alert System. It's part of the real-world, unglamorous routine of planetary defense. A sky-scanning network funded to spot near-Earth objects early, so we don't get blindsided by a rock with bad manners. And on the 1st of July, 2025, Atlas picked up something that didn't feel like a normal local object. Here's the first thing to understand about 3I, Atlas, before the internet turns it into a monster. The 3I part isn't a vibe, it's a label. It literally means third confirmed interstellar object. Before this, we had 1I Oumuamua in 2017, first of its kind, weird shape, weird behavior, and it left faster than your friend when the bill arrives. Then we got 2I, Borisov in 2019, a more classic Comet vibe, icy, active, gassy, something astronomers could recognize and explain with less headache. Then comes 3I, Atlas. And the moment it was confirmed as interstellar, the story changed. Because interstellar objects are not from the neighborhood. They're visitors. They don't orbit the sun like a normal comet. They cut through. Imagine your street, calm at night. Then a car you've never seen comes speeding through. Doesn't slow down, doesn't park, doesn't even look like it belongs there, and then it's gone. That's what this is, in space terms. NASA's own write-up is clear about the basics. 3I Atlas is moving too fast to be bound by the sun's gravity. Its path is hyperbolic, meaning it's not doing laps. It's passing through, then leaving for good. And for good is not drama, it's literal. If you miss your chance to study it up close, that's it. It won't come back. Now, let's deal with the number people keep repeating, like it's a horror movie tagline. Speed. Reports put it around 60 kilometers per second, which is about 37 miles per second. That's fast enough that your brain should translate it to, you don't get many second chances. We saw it. We reacted. We aimed everything we could at it. Because interstellar objects are like messages in bottles. You don't get to choose when they arrive. You only get to choose whether you're awake when they pass by. So observatories around the world start lining up real ones, not Reddit ones. NASA teams. The Minor Planet Center, collecting observations and tightening the orbit. NASA's JPL tools crunching trajectories so everyone can predict where it will be. Ground telescopes like Gemini, Keck, and ESO-class instruments, gathering light, spectra, color, motion. And above Earth, the big eyes turn. Hubble, the veteran, still delivering clean, sharp data. James Webb, the monster instrument built for deep time, now checking something much closer. And NASA also mentions SPHEREx in the context of studying it another way to get a better handle on what it's made of. Now, here's where the internet grabs the wheel and drives straight into a ditch. People see interstellar and they hear alien. That jump is understandable. It's also lazy. Because interstellar does not mean artificial. It means not from here. A rock from another star system is still a rock. But, and this is important, sometimes a rock can behave in ways that make even serious scientists uncomfortable. Because the data is limited, the object is small, and space is messy. That's why Oumuamua became such a legend. It looked like it had a weird shape, it didn't show a classic comet tail, and it had a small extra push in its motion, what people call non-gravitational acceleration. Harvard astronomer Avi Loeb became the most famous voice, saying, "We should consider the possibility it's artificial, at least as a hypothesis worth checking, not as a conclusion." A lot of other astronomers push back hard. People like David Jewett have laid out plenty of natural explanations for weird interstellar behavior. And the general rule in science is the rule you should use in life too. Don't pick the wild explanation when a normal one still fits. Carl Sagan said it in a way everybody remembers. Extraordinary claims require extraordinary evidence. So when 3I Atlas arrived, the world basically replayed the same argument, but with fresher data and better tools. And then the phrase final transmission started spreading like gasoline. Here's the truth. 3I Atlas did not send a message like a sci-fi beacon. No, hello, no, we are coming. No spooky audio. What people are calling final transmission is a mix of three things. 1, the last clean stretch of observations before geometry, distance, and glare make tracking harder. 2, radio observations looking for signs of technology because the public demands it now. And 3, a real signal, but not the kind you think natural radio emission that comets can produce. Let me explain that in plain language. A comet is not silent. When sunlight hits the ices, they heat up. Gas escapes. Dust gets dragged out. The coma forms. In that gas cloud, molecules can break apart. Some fragments emit at radio wavelengths. That can look like a radio signal if you're not careful with words. But it's nature talking, not technology. And that's exactly what some reporting has pointed to. Radio emissions consistent with known comet chemistry, not an engineered broadcast. At the same time, groups did real searches for artificial-style narrowband transmissions. That's a normal thing now. You check the sky, you listen, you publish limits. A scan coming back quiet doesn't mean nothing exists. It means during that scan, in that band, above that power level, we didn't see a technological transmitter. That's not a cover-up. That's how measurement works. Now, here's where the title earns its punch without lying. Because even if there's no alien broadcast, the data times still times warns us. And the warning is not about invasion. It's about exposure. Because this object showed up, and for a moment, it reminded every serious person in planetary defense of a brutal fact. We are not watching everything. We can't. The sky is huge. Our systems are improving, but interstellar objects are the ultimate fast surprise. They don't follow the usual patterns. They come from directions we don't always monitor equally well. They can cross dense star fields where detection is hard, and they move too fast for comfort. If the third confirmed interstellar object passed through in 2025, then how many passed through in 1925 when we had nothing like Atlas? How many pass through right now, too small and too dark for our surveys? That's the real chill, not they're coming. More like things come through here all the time. And we only notice when our tools get good enough. Now, 3I Atlas had a timeline that made the observing campaign feel like a countdown clock. NASA's public info includes key moments. It came near Mars on the 3rd of October, 2025. It reached perihelion around late October 2025, inside Mars's orbit. It made its closest pass to Earth around the 19th of December 2025, still far, not a threat. Then it keeps going outward, and NASA's own frequently asked questions mentions a big final encounter people keep pointing at. Jupiter in March 2026. That Jupiter pass matters for two reasons. First, it's the last major stage light moment. A big planet nearby means good geometry, good chance to study how the comet behaves as it moves through different conditions. Second, Jupiter is gravity with muscle. Even if the comet is unbound, Jupiter can still tweak the path a little. And observers love these moments because the math gets testable. This is where the story gets fun and tense at the same time. Because in the weeks after discovery, everyone wants answers to questions that sound simple, but are actually hard. How big is the nucleus? What is the surface made of? Is it dusty? Icy? How reflective is it? How fast is it spinning? Is it venting gas evenly or like a lopsided sprinkler? Is there non-gravitational acceleration? If yes, is it normal outgassing or something else? And that's where the final transmission vibe grows, because every new batch of data is like a last message before it fades into darkness. Now, let's talk about the part people twist into fear, the motion. When you hear it's accelerating, your brain goes straight to engines. But in comet science, small extra pushes can come from simple stuff. Sunlight pressure, jets of gas venting like tiny thrusters, uneven heating, a rotating body that vents more on one side than the other. If you've ever held a wet bar of soap and squeezed it, and it slips in an unexpected direction, you get the idea. Small forces add up when an object is light, icy, and active. And because 3I Atlas is interstellar, it might be made of ices and mixtures we don't see much in our own comet family. It could vent differently. It could carry more CO or CO2. It could be older and baked in weird ways, so you measure it carefully. That's where institutions matter. JPL's orbit tools, the Minor Planet Center's observation pipeline, teams at NASA Goddard doing spectral work, observatories like Keck collecting high-quality spectra, ESA-connected research communities comparing data, Harvard-Smithsonian researchers arguing in seminars, and yes, Avi Loeb and the Galileo Project voiced the test the artificial hypothesis angle because public interest is huge, and because scientists are allowed to ask uncomfortable questions as long as they don't skip the evidence part. So what does evidence look like here? It looks like boring, beautiful things. A spectrum with absorption lines that match known molecules. A thermal curve that behaves like an icy body. A coma shape that changes with solar heating. A light curve that reveals rotation, not a coded message. A radio search that finds nothing narrowband and artificial looking. And a trajectory that, while dramatic, still follows gravity plus known small physics. The more measurements you get, the less room there is for fantasy. And that's exactly why the final transmission meme is so effective online, because it feeds on the gap between what people want and what science actually delivers. People want a sentence. Science gives you a graph. People want a villain. Science gives you uncertainty bars. People want certainty. Science gives you, it depends. Let's measure again. Now here's the moment I want you to picture. It's late 2025. 3I Atlas has already made its close moments. Mars, perihelion, Earth's closest approach. It's moving away. It's getting dimmer. And that means every week you need bigger telescopes to get the same quality of data. The object shrinks into the noise. That's what final really means here. Not final words. Final good look. Final clean signal to noise. Final chance to learn something without guessing. And in that last stretch, the world splits into two groups. Group one says, it's a comet, a rare one. Study it, learn from it, move on. Group two says, you're missing the point. The pattern is the point. Because before 2017, we had 0 confirmed interstellar visitors. Then we got one, then another, then another. And in the background, the Vera Rubin Observatory is coming online to watch the sky with a level of speed and depth we've never had before. So what happens when Rubin really starts running? You know the answer. We stop seeing interstellar objects as once-in-a-lifetime myths. We start seeing them as traffic, and that is the warning. Because traffic means two things. One, the galaxy is throwing stuff around constantly. Planet formation is messy. Star systems eject leftovers like spitballs, and those leftovers wander too. If that's true, then interstellar objects aren't rare in reality. They're rare in our current detection ability. And that means the universe has been sending visitors through our solar system for billions of years. We're just finally old enough as a species to notice. And if you're looking for something that should humble you fast, it's that. Now, before we hit the key moment, let's deal with the scariest idea people whisper but don't define. What if it's watching us back? Here's the honest answer. We have no evidence that 3I Atlas is an observing machine. But we do have evidence that we are turning ourselves into a bright, obvious civilization. We leak radio. We have radar. We send signals. We light up our planet at night. We're launching more spacecraft. We're building better telescopes. If you want a watching story that's real, it's this. We're becoming easier to detect. So the uncomfortable thought isn't that 3I, Atlas is spying. It's that interstellar space is not empty, and any civilization with better instruments than us could have noticed Earth a long time ago. That's not fear. That's logic. Now, let's bring it back to something you can hold in your hands mentally. Think about how you judge a car speeding past you at night. You don't see the driver. You don't know the destination. You get a glimpse of shape, speed, sound, reflection, and your brain will try to fill in the blanks. That's what's happening here. We see a fast visitor. We measure what we can, and where we can't measure, people invent. So if you want the truth, you follow the data, not the drama. Which brings us to the moment people are calling the final transmission. It's the last major slice of information that will shape how history remembers 3I Atlas. Not because it said something, because it forced a decision about what kind of species we are. Do we panic and fantasize? Or do we do what NASA, JPL, ESO, Keck, and every serious observatory does best? We measure, we compare, we publish, we correct, we learn, and then we use that knowledge to prepare for the next one. Because there will be a next one. That's not a guess anymore. That's the direction the evidence is pointing. Number problem. Here's the problem nobody likes saying out loud. Interstellar objects don't give us time. They don't orbit politely. They don't announce themselves years ahead like some comets do. They show up already moving fast, already fading, already halfway through the scene before the cameras even roll. That means the early hours matter. The first week matters, and misinformation moves faster than telescopes. So while scientists are doing careful work, tightening orbits through the Minor Planet Center, running ephemerides through JPL, scheduling time on Webb and Hubble, social media is already declaring motives. That's the real danger zone. Not the object, but the story we build around it. Because a story can cause panic. A story can trigger fake warnings. When formants, a story can make people distrust real science. And the public deserves better than that. So the challenge is, how do you take a genuinely rare interstellar visitor and talk about it in a way that is exciting without lying? Number exploration. You do it the same way astronomers do it. You squeeze meaning out of light. You treat the comet like a lab sample that you can't touch. First, you check the orbit. Interstellar means hyperbolic, unbound, not captured by the sunday. That's math, not opinion. Then you study the coma and tail behavior. If it's active, it's probably icy. If it's inactive, it could be rocky, or it could be a comet that isn't outgassing much yet, or outgassing in a way that's hard to see. Then spectroscopy. Spectroscopy is the universe's barcode scanner. It tells you what molecules are present by how they absorb and emit light. You want to see patterns that match known comet chemistry. Then photometry. Light curves can reveal spin. A rotating object flashes brighter and dimmer in a pattern, like a slow lighthouse. And here's something important. Humans love to call any repeating pattern a message. But nature makes repeating patterns all the time. A spinning potato-shaped comet will do it. A lopsided coma will do it. A jet that turns on and off as the comet rotates will do it. A pattern is not proof of intention. It's just a clue. Now you bring in radio observations. Because once the public starts yelling alien probe, radio becomes the fastest way to test the loudest claim. You listen for narrowband signals. You look for something that stands out from noise and doesn't match natural emission. And what happens if you don't find anything? Then you've learned something valuable. If there's a transmitter, it's not shouting. If there is technology, it's not obvious. Or more likely, it's just a comet doing comet things. And even when you detect radio emission from a comet, that can still be completely natural, like hydroxyl created from water chemistry in the coma. So the exploration phase becomes less about fear and more about a quiet scientific reality. We are learning what another star system's leftovers look like. We're looking at a sample from somewhere else. That's rare. That's valuable. That's worth attention. And now, when the object is moving outward, dimming, and heading toward its last big encounter, Jupiter, in March 2026, you realize something. This is the last time it will ever be close in any useful way. After Jupiter, it's basically goodbye. And that's when the data starts to feel like a voice. Not a literal voice. A voice in the way footprints are a voice. A voice in the way a fossil is a voice. A voice in the way an old photo is a voice. It doesn't talk, but it tells you something true. Number, climax. So here's the key moment, what people are actually reacting to when they say final transmission. It's when you zoom out and realize the warning isn't aliens. The warning is this. We are living through the moment when the solar system stops being a closed neighborhood. For most of human history, we could pretend the solar system was like a fenced yard. Comets came from our own distant reservoirs. Asteroids belonged to our own family. Everything was local. 3I Atlas breaks that comfort. It is proof that the fence is imaginary, that things from other star systems can cross our path, and we won't always see them early. Now connect that to Jupiter. Jupiter is not just a planet. It's a gravity gatekeeper. It shapes traffic. It tugs, redirects, protects us sometimes, and also flings things sometimes. So when an interstellar object passes Jupiter, you're basically watching a pinball machine. If it's a normal comet, Jupiter's role is still huge. We learn how gravity and outgassing interplay at high speed, and we tighten models for future visitors. If it's weird, then Jupiter becomes the moment where weirdness gets tested hard. And that's why serious people want that March 2026 window studied as much as possible. Not because they expect a spaceship to pop open like a toy, because it's the last strong checkpoint in a fast story. And here is the real warning the world should take from the final clean dataset. If a small interstellar object can enter our solar system and become global news only after it's already deep inside, then the next one could be smaller, darker, and harder. And the scary part is not science fiction. The scary part is we might not notice until it's already gone, or until it's close enough that there's no time to do anything about it. That's why NASA funds surveys. That's why Atlas exists. That's why Rubin matters. That's why planetary defense is not a joke. So the final transmission, if you want the honest translation, is this. This comet didn't warn us with words. It warned us by existing. It reminded us that space is not quiet. It's not empty, and it's not waiting for us to feel ready. Number conclusion. So where does that leave us? It leaves us with a rare gift, an interstellar sample we can study without leaving Earth. It leaves us with better tools than we had in 2017, and better discipline than we had during the first wave of Oumuamua panic. It leaves us with a reality check. Interstellar objects are not a once-in-a-lifetime myth anymore. They're a category, and as our telescopes improve, that category is going to fill up fast. Some will look normal, some will look strange. A few will spark debates that never fully die, but the smart move is the same every time. Don't worship the mystery, measure it. Because the universe doesn't reward panic, it rewards patience. And the best part is, we're getting better at this. With every new survey, every spectrum, every orbit refinement, we go from fear of the unknown to map of the unknown. So if you felt that chill when you heard final transmission, keep it, but aim it in the right direction. Not toward aliens, toward preparedness, toward better science, toward the simple truth that the solar system is open to the galaxy, whether we like it or not. 3I. Atlas was first reported on ***, the 1st of July 2025, ***, by the **** Atlas Survey Telescope in Chile, ***, and it went straight to the *** Minor Planet Center, ***, the official clearinghouse that collects observations and pins down orbits. NASA Science 1. That sounds routine, like paperwork. But that first report is the moment a moving dot becomes a real object in the human record. Because at the beginning, you don't know the path. You're guessing the path. It's like seeing a single frame of a car on the road and trying to predict where it'll be tomorrow. You need more frames. So other telescopes jump in. Hawaii, Europe, South Africa, anywhere with clear skies and time on the schedule. And every new observation is another frame. The Minor Planet Center uses those frames to tighten the orbit. NASA's orbit tools, run by teams that include ***, NASA JPL, ***, keep refining it too, because you need a clean answer to the most basic question. Is it bound to the sun, or is it passing through? And for 3I, Atlas, the answer became clear, fast. Asterisk, it's interstellar, asterisk. Hyperbolic, not here to stay. NASA Science 1. Now, this is where people get confused. They hear not bound and imagine it's ignoring gravity like a magic trick. No, gravity still works. It's just moving so fast that the sun can't capture it into a looping orbit. Picture throwing a baseball past a magnet. If you throw it slowly, the magnet pulls it in. If you throw it fast enough, the magnet tugs it a bit, but it still flies by. That's what hyperbolic means in plain words. So the first big job is measure its motion so well that we can predict where it will be weeks and months ahead, because this is a fast visitor and time is everything. NASA's public timeline puts key moments on the calendar. First report, ***. The 1st of July, 2025, ***. Then later, it passed important geometry windows, and it's expected to make a notable pass near *** Jupiter in March 2026, NASA Science 1. And those windows matter because they decide what we can learn. People think telescopes just look at an object and tell you the truth. In reality, astronomy is like trying to identify a stranger across a football stadium while fog drifts by and someone keeps turning the lights on and off. You can still do it, but you do it with method. Here's the method, in the most human way I can say it. First, brightness. How bright is it? Brightness sounds simple until you realize it can lie to you. A small object with a shiny surface can look like a big object with a dull surface. So if you don't know reflectivity, brightness doesn't tell you size. That's why the conversation around interstellar objects always has this, wait, it's too bright, it's too small, it doesn't match vibe. Because we often have to infer size from light, and light depends on surface behavior. Second, color and spectrum. This is where the grown-up tools come out. With spectroscopy using observatories like Keck and ESO class instruments, you break the light into a rainbow and look for fingerprints of materials, water-related fragments, carbon-bearing molecules, dust behavior. All of that can show up as patterns in the data. NASA describes 3I Atlas as an ***, interstellar comet ***, meaning there's comet-like activity, not just a dead rock. NASA Science 1. Third, shape and spin. If its brightness rises and falls in a repeating way, that can reveal rotation. If jets flare, that can reveal active regions. And here's a detail that made scientists lean in harder. A new set of observations reported unusual comet activity, jets, and even a rare sun-facing anti-tail effect, plus a wobble pattern that implies a rotating nucleus. Space too. This matters because it gives you a natural mechanism for weird behavior. Jets can push. Rotation can modulate jets. Modulated jets can create small changes in motion that look spooky if you don't have enough data. That's the difference between a headline and a measurement. A headline says, it changed course. A measurement says, it's rotating, venting, and the jets act like tiny thrusters. Now, let's talk about the phrase in your title, final transmission. Because if we're being strict, 3I Atlas is not a spacecraft sending a voice message. But it did produce something that times like a transmission in the modern world, because we now treat data like language. Every time the object's light curve updates, it's speaking. Every time the spectrum changes, it's speaking. Every time the orbit fit tightens, it's speaking. And there's a real reason people call the last clean data a final moment. Because as an object moves away, it doesn't just get farther, it gets harder. The light gets weaker. The background gets messier. The best geometry windows end. Sometimes the object goes near the sun in our sky, so we can't safely observe it as well from Earth for a while. Sometimes it's just too dim for most telescopes, and only the biggest instruments can still grab usable measurements. So final often means final stretch where normal observatories can still do high quality work. And in the case of 3I, Atlas, there's reporting that it even brightened dramatically behind the sun. Changing the observing situation and feeding the something is happening energy. Futura 3. Now, you might be wondering, okay, if it's just a comet, why did the world go crazy? Because this is the third interstellar object we've confirmed. 3 doesn't sound like a lot, but in science, it's a turning point. 1 is a fluke. 2 is a coincidence. 3 is when people start saying, this is a category. And NASA's own page treats it like that, an interstellar comet discovered by a survey system doing planetary defense work. NASA Science 1. So the warning angle that actually holds up is not aliens. It's interstellar traffic is real, and we're finally building the tools to notice it. That's where the Vera C. Rubin Observatory comes into the story like a giant spotlight. Rubin isn't going to prove aliens. Rubin is going to do something far more disruptive. It's going to find more fast movers earlier. It will turn the sky into a time lapse, night after night after night. So objects don't just appear as a rumor, they appear as a track, a trail, a clear path with context, which means this exact era might be the last era where an interstellar visitor feels like a mythical one-off. After Rubin, interstellar objects might become normal news, and that will change how we talk about them. Now let's address the part you included in your script. Info that's emotionally powerful, but needs to be handled carefully so you don't build your whole video on shaky ground. The "it" accelerated in a way sunlight can't explain claim. That exact sentence is what created the Oumuamua storm in 2017. With Oumuamua, a small, non-gravitational acceleration was reported. And because there wasn't an obvious comet tail, it sparked huge debate. Avi Loeb became the most famous voice arguing we should consider an artificial origin hypothesis. He's still active in this space today, including writing about 3I, Atlas observation geometry, like a near opposition alignment in January 2026. That could help measure brightness behavior, medium 4. But here's the important line you need in your script so you don't get called out. A non-gravitational acceleration does not automatically mean engine. Comets can do that naturally. Outgassing is literally a built-in jet system. Sun heats one side, gas vents, the object gets a tiny push. And that push can look controlled. If the spin is stable, the jets are localized, and you're measuring it with high precision. So the real scientific game is, can we explain the motion with known comet physics? If yes, the story is still fascinating because it's an interstellar comet and we're studying material from another star system. If no, then you don't jump to aliens. You first check measurement error, uneven dust coma effects, solar radiation pressure modeling, and whether you're missing a weak tail or gas line. And this is why big institutions matter. Because it's not one person deciding this. It's multiple teams using multiple instruments, cross-checking each other. NASA, the Minor Planet Center, JPL orbit fits, ground observatories, space telescopes. And when the public wants proof, the scientific community answers with the most honest thing it can give. More data, better constraints, smaller error bars. That's also why groups like Breakthrough Listen, got pulled into the story. Because once the public starts saying probe, somebody is going to listen for technosignatures. And Breakthrough Listen did search during a key window and reported what they did and didn't find. IF Science, 5. Now here's where your title can land its punch without lying. Final transmission can mean final clean window of data, combined with the last and best Techno signature search window, combined with the last time we can measure certain properties with confidence. That is dramatic. That is real. And it's not sci-fi fan fiction. So what could the warning reasonably be? Here are 3 warnings that are actually strong and defendable. Warning hash shown. The solar system is not a closed neighborhood. If 3 confirmed interstellar objects can pass through in under a decade, then the galaxy is constantly swapping debris. We were just blind before. NASA Science, 1. Warning hash 2. We have blind spots. Atlas found this one, but it also proves the uncomfortable truth. The faster something is, the less time we have to react. You don't get years. You get weeks and months, sometimes less. Warning hash 3. Our own capability is the trigger. It's not that space suddenly got busy. It's that our surveys got good enough to notice. And the better we get, the more impossible things will become normal. Now, if you want this script to truly stretch to a relaxing 2 hours without feeling like filler, you do what real documentary pacing does. You zoom in. You take the same story and walk the viewer through it like they're standing beside you at a telescope. So let's zoom in on the day it was spotted. Picture a scientist looking at a feed of sky images, thousands of points of light. Most of them don't move. A few do. Most of the movers are known, cataloged, boring. Then there's one dot that moves with the wrong swagger. It doesn't follow the rhythm of local objects. And the first reaction isn't fear. The first reaction is, did we mess up the data? Because nobody wants to be the person who accidentally announces a cosmic event that turns out to be a camera artifact, a satellite, or a misidentified object. So they check, they recheck, they get independent confirmation. Then it goes to the Minor Planet Center. Then it gets a provisional designation. Then the orbit tightens. Then somebody runs it backward and sees it didn't come from the Oort cloud, like a normal long period comet. And at that moment, a quiet line is crossed. Because once it's interstellar, you're not just doing comet science. You're doing archaeology of another star system. You're holding a clue from somewhere else. And that's why the biggest telescopes come out. That's why Webb gets attention, because Webb can look at heat signatures and composition clues in a way that helps break the bright but small confusion. That's why Hubble still matters, because it has a long record, stable imaging, and it can contribute constraints you can compare across time. That's why Keck matters, because a giant ground mirror plus spectroscopy can tell you what the coma is actually doing. And that's why ESO's network matters, because different instruments, different skies, different checks. So when people say NASA confirmed it, what they really mean is the world's measurement machine turned on. And it didn't turn on because of fear. It turned on because this is rare. Now let's add the detail that makes the story feel even more alive. The timeline checkpoints. As it approached the sun, observers reported changes like that anti-tail behavior and evolving jets. NASA's own timeline emphasizes how discovery and tracking unfolded, and reporting around its closest approach era shows it behaving like an active comet, not a dead rock. NASA Science 1. And that's important because it means the final data isn't just one moment. It's a whole season of observation, a season where the comet becomes a living thing, brightening, shedding, changing shape before it fades again. Now, here's a calm but chilling question you can ask right here in your script to keep people locked in. If this is the 3rd interstellar visitor we've noticed, how many have passed through without us ever seeing them? Not because they were hiding, because we weren't looking well enough. That question lands hard because it turns the whole story inward. It's not about what 3i Atlas is. It's about what we are. We're a young species with new eyes. We're finally building systems that make the solar system feel less like a quiet backyard and more like a shoreline, with things washing up from far away. And that brings us to a moment that you can stretch out beautifully in a relaxing tone. The moment when scientists realize the public story and the data story are drifting apart. The public story becomes final transmission. The data story becomes the last high-quality window before it gets too faint and the geometry gets worse. And that gap is where the algorithm loves to live. because the algorithm loves mystery, but it also loves authority. So the winning move in your script is to be the calm voice in the middle. Yes, this is strange. Yes, this is rare. No, we're not going to fake the evidence. Here's what we actually know. Here's what we can actually test. And then you start building suspense. Again, not with aliens, but with the real stakes. The next interstellar object could arrive from a direction we're not watching well. It could be darker, smaller, faster. And if it passes inside the orbit of Mars, before we get solid data, we might only get a few days of clean observing before it's gone into glare or faded into noise. That's why the warning is real. Not because 3I Atlas threatened us, because it reminded us what the universe is like when you finally open your eyes. Things happen whether we're ready or not. One of the biggest mistakes people make with interstellar objects is thinking the answer should pop out fast, like a magic trick. But in real astronomy, the object doesn't hand you its ID card. You have to times it, piece by piece, with light. So when 3I Atlas came in, the first real question list inside the science teams wasn't aliens or not. It was more like, what's the coma made of? How dusty is it? How much gas is it releasing? Does it behave like a normal comet when it warms up? And can we explain every little wiggle in its motion using normal physics? Because if you can answer those, you don't just learn about this one object. You learn something bigger, what other star systems make, and how common these visitors might be. Now, NASA's page calls 3I Atlas an *** interstellar comet ***, and it lays out the key timeline in plain terms. Closest to the sun around *** October 30, 2025, about *** 1.4 AU ***, just inside Mars's orbit, closest to Earth, around *** 1.8 AU ***, and then heading outward with a pass by. ***, Jupiter in March 2026. ***, NASA Science 1. Those dates matter because comets don't behave the same at every distance. Far from the sun, they can look quiet. Closer in, they can wake up jets, dust, changing brightness, the whole show. And that's exactly why the phrase final transmission sticks to the timeline. Because there's a stretch where the comet is bright enough and close enough that the data is clean, and then it slowly fades into the background like a car taillight disappearing down a long road. So here's what scientists did during the best window. They used multiple lenses, literally. NASA even published a piece about seeing 3I Atlas through different NASA assets. One example is imagery from ****punch, ****ah. NASA mission designed to image the solar, corona, and heliosphere, showing the comet in a way most people don't expect. NASA Science 2. And when you combine different kinds of views, optical, infrared, sometimes even space weather style instruments, you start to get a real personality profile, not a rumor profile, a physics profile. Now let's talk about the most important thing most viewers don't realize. ***. Brightness is not just brightness. ***. If a comet gets brighter, it might be because it's getting closer to the sun. It's becoming more active. It's throwing off more dust. Dust reflects light well. Or you're getting better viewing geometry from Earth. And sometimes the geometry is the whole trick. If a comet passes behind the sun from our viewpoint, you can lose good observations for a bit. Then it pops back out, and people act like it returned with a message. No. It returned to a better angle. NASA's own frequently asked questions mentions the behind-the-sun timing around late October. NASA Science 3. That's not a conspiracy. That's just how viewing works. Now, while all this is happening, the loudest public claim starts floating around. Okay, fine. Maybe it's a comet. But what about a signal? So here's the honest way to handle that claim without killing your video's vibe. You explain that there are two different signal ideas people mix up. Asterisk, asterisk. Signal, type A, natural emission from a comet. Asterisk, asterisk. Comets can produce radio emission tied to chemistry in their coma. It's not a voice. It's more like the chemical steam showing up on sensors. Asterisk, asterisk, signal type B, a techno signature. Asterisk, asterisk. This is the sci-fi flavored one. Narrowband radio tones, unnatural patterns, power levels that look engineered. If you want to test type B, you don't guess. You point a serious radio telescope and you listen. And that's what happened. During 3I, Atlas's closest Earth approach window, the asterisk asterisk breakthrough listen asterisk asterisk program used the asterisk asterisk Green Bank telescope asterisk asterisk to run a technosignature search in the asterisk asterisk 112 gigahertz's asterisk asterisk range, and they reported a asterisk asterisk non-detection asterisk asterisk down to very low power thresholds. They quantify it in the paper. ArcSiv 4. That's huge, because it's the closest thing to a clean answer you can give people who are honestly curious. It does times not times prove no aliens. We have also odd. It does times not times prove no technology. It proves something more specific and more useful. During that observation, at those frequencies, above those sensitivity limits, they didn't see a narrowband artificial style transmitter. So if the public is demanding a final transmission, the reality is almost the opposite. The most careful listening session we've seen publicly came back quiet, RxSiv 4. And that quiet is powerful because it forces the story to grow up. It pushes the video away from Hollywood fear and toward the real warning. Interstellar visitors are real, they're rare to catch, and the best response is better detection, not panic. Now let's zoom in again, because this is where your pacing can stretch for a long time without feeling like filler. When astronomers watch a comet, they're watching a moving factory. The sun is the heater. The comet is the ice and dust machine. The coma is the cloud. And the tail is the exhaust. The factory changes day to day. Jets can switch on. Jets can switch off. The tail can look like one tail, then two tails, depending on dust and ion behavior. Sometimes you even get strange looking geometry effects. And a lot of viewers hear anti-tail and their brains go, that sounds engineered. But an anti-tail can happen naturally when dust sits in the comet's orbital plane and the viewing angle lines up just right. It's basically perspective playing tricks. Observers reported striking jet activity and unusual tail behavior for 3I Atlas during the close approach season. And those details are exactly the kind of thing you'd expect astronomers to document because it tells you how active the comet is and how its dust behaves. Space 5. So here's a calm but gripping way to frame it in your script. Imagine you're watching a spinning lawn sprinkler in the dark with a flashlight. If the sprinkler is steady, the spray looks patterned. If the sprinkler wobbles, the pattern changes. If one nozzle is clogged, the push changes. If you move your flashlight, the whole thing looks like it shifted behavior. That's a comet. Now, one of the biggest algorithm-friendly hooks you can keep reopening is this. Why are we seeing more interstellar objects now? And the answer is simple and slightly humbling. We built better eyes. Before 2017, we had no confirmed interstellar objects. Now we have 3. That doesn't necessarily mean the galaxy suddenly got busy. It means our surveys reached the level where we can catch fast, faint movers. Atlas is built for this kind of discovery pipeline. And 3, iAtlas is basically a proof of work stamp for that whole approach. Minor Planet Center, 6, and that's where the real tension in the story sits. Because if 3 interstellar objects have been confirmed in the time when we're actually paying attention, then interstellar visitors might be way more common than most people think. Not common like every week, but common like there's always a few passing somewhere, and we miss most of them. And once you say that out loud, you can feel the warning without inventing anything, because it means the solar system is not sealed. It's more like a shoreline. Stuff washes in, stuff washes out. Now, this is the part where we bring in the big names naturally, like a documentary does, without stopping the flow. When NASA's teams publish a timeline and say, no threat, that's not them being casual. That's the result of orbit work and tracking the same kind of careful math you see come out of asterisk asterisk JPL, asterisk asterisk for objects that matter. NASA Science 1. When the orbit is refined through the asterisk asterisk minor planet center asterisk asterisk, that's not one guy with a telescope. That's a global pipeline hosted by the Center for Astrophysics or Everett and Smithsonian, where professional and amateur data gets fused into one official solution, Minor Planet Center. 6. When people want to search for text signals, asterisk asterisk breakthrough listen, asterisk asterisk doesn't do vibes. They do structured searches with large instruments like Green Bank and publish what they find, even when the answer is nothing obvious. RX 4. And when researchers argue publicly, like Avi Loeb often does, about what to test next, the healthiest way to handle that in your story is not to treat it like a fight. It's a stress test. Loeb pushes one side. Don't dismiss the artificial hypothesis too early. Many others push back. Don't jump past natural explanations without extraordinary evidence. That tension is normal in science when the object is rare and the data window is short. Now, remember that Jupiter checkpoint in asterisk asterisk March 2026 asterisk asterisk? Here's why that's such a juicy story moment without inventing anything. Jupiter is basically the solar system's bouncer, not in a dramatic it attacks objects way, in a gravity way. It's the biggest planet. It shapes paths. It can alter the angle an object leaves on, even if that object is unbound overall. So when 3I Atlas swings past Jupiter on the way out, you get one last big chance to compare predictions to reality. Does the coma behave the way we expect at that distance? Does activity fade smoothly, or does it pulse? Does the orbit match the refined ephemeris cleanly? That's the final transmission, in a real scientific sense. The last moment where the comet can still be tracked with strong confidence before it slips into the deep freeze of distance and becomes just another faint point. They try to break the weird claim, because in astronomy, the most dangerous thing isn't being curious. It's falling in love with one explanation too early. So when people say it's navigating, or it changed course, or it's sending a warning, the real response from serious teams is, show me the residuals. Residuals is just a fancy word for the difference between what the math predicts and what we observe. If your prediction says the object should be here, and it's actually there, the gap between those two is the residual. And if that gap keeps repeating in the same direction, in the same pattern, even after you fix every normal cause, then you've got something real. Not real aliens. Real physics you don't understand yet. So what's the checklist of things that can make a comet look like it's doing something on purpose? First culprit, bad data. This one is more common than people want to admit. Sometimes the dot is near a crowded star field, and your measurements are slightly off. Sometimes the comet's coma is fuzzy, and you're not tracking the nucleus perfectly. Sometimes different observatories have tiny calibration differences. Sometimes you think you're measuring the center of the object, but you're measuring the brightest part of the dust cloud around it. And if you're off by a tiny amount, night after night, it can look like the object is drifting from its predicted path. So the first job is to clean the data. That's why the Minor Planet Center pipeline matters so much. It doesn't just collect observations. It helps filter, compare, and standardize. And it's why orbit teams at places like NASA's Jet Propulsion Laboratory do not trust a single observation set. They want many from different places across time. Second culprit, sunlight pressure. Sunlight has momentum. It can push. It's tiny, but if an object is light and has a lot of surface area compared to its mass, sunlight pressure can matter. This is one reason thin, flat objects became such a big talking point during the Oumuamua debates. If something is sheet-like, it can be pushed more. But comets are usually not sheets. They're lumpy, dirty, and heavy enough that sunlight alone is not a magic engine. Still, you check it. Third culprit, outgassing. This is the big one. Outgassing is a comet's built-in thruster system, whether it wants to be one or not. You heat one side, gas vents out. That vent produces a tiny push. And if the venting is uneven, the push is uneven. Now add spin. If it spins like a top, the jets sweep around and the push averages out more. If it tumbles, the jets act weird and the push changes unpredictably. Either way, the motion can deviate slightly from pure gravity. That's normal comet behavior. So the real question becomes, is the extra motion consistent with outgassing? How do you test that? You don't just stare at the orbit and guess. You watch the coma. If outgassing is driving motion, you often see changes in brightness, jets, and tail behavior that line up with the physics. You also look for gas species in spectra. You look for CO, CO2, water fragments, dust production. The details depend on the instrument, but the concept is simple. If it's pushing itself by venting, it should be leaving chemical fingerprints. That's where big observatories come in. Keck can take high-quality spectra. ESO instruments can do the same from other skies. Hubble can help in certain bands. Webb can check heat behavior and composition clues. And even when you don't get a perfect chemical readout, you still have a strong clue. If the object looks active like a comet, then a small non-gravitational push is not shocking. Fourth culprit, a sneaky one called coma drag on measurements. Here's what that means in plain words. Imagine you're trying to track a moving car at night, but the car is inside a fog cloud. Sometimes you accidentally track the brightest fog, not the car. So your position measurements drift. Now translate that to a comet. If the coma is uneven, your astrometry can get biased. So teams are careful. They model the coma, they correct for it, they cross-check. That's why the truly weird claim is hard to earn, because there are so many normal ways to fake it. Now, let's say you've done all that. You cleaned the data. You accounted for sunlight pressure. You accounted for outgassing. You corrected for coma bias. And you still see a residual that won't go away. That's when scientists get quiet. Because if there's one thing the universe loves, it's humbling us in slow motion. But here's the most important part for your video. A stubborn residual doesn't automatically mean a spacecraft. It means we need a better model. In the history of science, the biggest breakthroughs often started as small residuals. Mercury's orbit had a tiny mismatch that helped lead to general relativity. Galaxy rotation curves didn't match gravity predictions. And that helped push the dark matter problem into focus. So residuals are serious. They're also not proof of intention. Now, this is the point where your title, Final Transmission, can stay dramatic without lying. Because the warning can be framed like this. 3I. Atlas isn't a talking probe, but it is a stress test. It forces our tracking systems, our modeling, our observation, coordination, and our public communication to prove themselves in real time. And the last good stretch of data, before the object fades, is the last chance to tighten those models. So what do scientists do in the last strong window? They do something very simple. They try to predict the future, not in a psychic way, in a math way. They say, based on everything we know now, here is exactly where it should be next week, next month, next season. Then they observe. And if the object lands exactly where predicted, the story calms down. If it doesn't, then the story heats up. That's why the end of the observation season feels like a final message, because it's the last test you can run while the object is still bright enough to measure precisely. Now, there's another layer to this that people don't talk about enough, and it's quietly terrifying in a very real way. Interstellar objects don't just test physics, they test coordination, because when something rare shows up, everyone wants telescope time at the same time. And telescope time is like a luxury hotel during a festival, fully booked, so teams have to negotiate, prioritize, share. You've got planetary defense survey teams feeding positions, orbit calculators updating predictions, big observatories scheduling follow-up, space telescopes that have their own packed science calendars. James Webb, for example, wasn't built to watch comets. It was built to watch the early universe. So when Webb looks at something like this, It's because the scientific value is huge, and because the window is fleeting. That alone should tell a viewer, this is real. No serious team re-aims precious instruments for a meme. Now, let's talk about the transmission idea one more time, because people love it and you can use it carefully. There's an old concept in astronomy tied to the idea of probes, associated with Ronald Bracewell at Stanford, where you imagine an automated messenger waiting quietly and responding only when a civilization becomes capable of noticing it. It's a thought experiment, a way to explore possibilities, not a claim that anything is happening here. So, if you mention it in your script, you have to keep it in the right lane. It's a concept that helps frame questions, not a conclusion from the data. And this is the smart way to use it. You say something like, some people bring up the Bracewell probe idea. It's interesting. But ideas are cheap. Evidence is expensive. So the question is, what would count as evidence? Then you bring the viewer right back to the checklist. And here's where we tighten the suspense again. Because there are a few specific things that would be genuinely hard to explain naturally. Not impossible, hard. 1. A repeated narrowband radio tone that tracks the object and behaves like technology, detected by serious programs, confirmed by independent instruments. 2. An acceleration pattern that changes direction in a way that doesn't match outgassing, sunlight pressure, or rotation. 3. Surface reflectivity and thermal behavior that can't be matched by known comet materials, even after you allow for weird interstellar chemistry. 4. Evidence of shape features that imply manufactured symmetry, and it holds up across multiple observation methods. Now, notice what all 4 have in common. They require multiple independent checks. That's why the breakthrough listen work matters. Even a non-detection is part of the story, because it sets limits, and the limits help you say, calmly, if there's anything artificial here, it's not shouting at us, which leads to a creepy but rational thought. If something wanted to be seen, it could make itself obvious. So if it's not obvious, the most likely answer is still the simplest one, a comet. A rare one from another star system, but still a comet. Now, here's the part where we widen the lens again, because this is where your 2-hour pacing gets rich. 3, iAtlas isn't just one object. It's the third domino in a sequence. Oumuamua in 2017 forced us to admit interstellar objects are real. Borisov in 2019 showed us an interstellar comet can look more normal. 3i Atlas in 2025 is now giving us a chance to test our systems when the public is watching, when the tools are better, and when the science community is already alert. And the next domino is going to be caught even earlier because detection is improving. That's why the Rubin Observatory matters again, like a shadow looming over the whole story. Because when Rubin starts catching interstellar visitors more regularly, the public's emotional response will change. Right now, 3 feels like an omen. Later, 3 might feel like a warm-up. And when interstellar objects become regular rare, the story becomes less about fear and more about learning. We will start comparing them like we compare meteorites. This one is richer in carbon. This one outgasses differently. This one is dustier. This one is darker. And that is when the real science gets exciting. Because you can't build a theory from one specimen, but you can build one from 20. Now, we're almost at the point where the story naturally leads into the warning that actually lands hardest. And it has nothing to do with aliens. It has to do with the direction 3i Atlas came from, and what that implies about where interstellar debris might be coming from in general. Because if these objects are being ejected from star systems all across the galaxy, then space between stars is not just empty distance. It's a highway of leftovers. And if it's a highway, then the solar system is not isolated. It's exposed. Not exposed in a we're doomed way. Exposed in a we are part of a larger environment way. The moment everything tightened wasn't a spooky voice from the stars. It was a spreadsheet problem that refused to behave. After months of tracking, the orbit fits got cleaner and cleaner thanks to the Minor Planet Center collecting observations from all over the world. and the usual orbit work that teams like NASA's Jet Propulsion Laboratory build into their pipeline. The wiggle room shrank. The noise got pushed down. And that's when the object stopped being a dot and started being a test. Because in that late window when 3I, Atlas was already past its best angles, already fading, already heading outward. Scientists did what they always do when something smells weird. They tried to make it boring. They reran the orbit again and again. They corrected for coma bias, because with comets, you can accidentally measure the bright dust cloud instead of the true center. They accounted for sunlight pressure. They modeled outgassing because a comet can push itself naturally with jets, like tiny one-sided exhaust. And then came the part the public calls a final transmission, even though it isn't a message. It was the last stretch where the data was clean enough to answer the question everyone kept circling without saying it out loud. Is there anything here that times can't times be explained by normal comet physics? This is where the story splits into two very different realities. In the internet reality, you get dramatic sentences. It's navigating. It's watching us. They shut it down. In the science reality, you get one brutal sentence. Show me a residual that survives every correction. So they chased residuals. They looked for a motion change that did not match outgassing. Not outgassing we didn't notice, but outgassing that would have to be there and would have to leave chemical or brightness clues and would have to show up in the coma behavior. They looked for acceleration patterns that flip direction in ways a rotating venting nucleus usually doesn't. They looked for symmetry, where symmetry shouldn't survive billions of years of micrometeoroid hits. They looked for heat behavior that doesn't match ice and dust. And while those checks were happening, the most public Are We Alone? Tests ran too, not with vibes, with hardware. Breakthrough Listen pointed the Green Bank telescope and listened in the kinds of radio bands where a loud, engineered transmitter would stand out. And it came back quiet. Not case closed, but quiet in the specific scientific way that matters. No narrowband techno signature signal above their sensitivity limits during that window. Quiet enough to force everyone to face the boring truth again. If this thing is artificial, it's not shouting, and if it's not shouting, the simplest explanation rises back to the surface like a cork. It's a natural interstellar comet, doing natural comet things just from a different star system. That's the first punch. Then the second punch lands, because even if it's just a comet, it still carried a warning that hits harder than any alien story. It warned us that interstellar space is not empty, it's active. It's throwing objects around like a messy kitchen after a party, and we're only now becoming capable of noticing. That realization hits like a cold shower when you remember the timeline. Before 2017, we had 0 confirmed interstellar visitors. Then we got one Oumuamua, and it was weird enough to make serious people argue in serious journals. Then 2 Borisov came through and behaved more like what we expected. Then 3 Atlas arrived, confirmed as the third. And it showed up in an era where our surveys are faster, our pipelines are tighter, and our biggest instruments are ready to pivot. In other words, it didn't become a big story because the universe changed. It became a big story because we did. We built Atlas to catch fast surprises. It caught one. We built orbit tools good enough to nail a hyperbolic path. We nailed it. We built Webb to read faint chemistry with insane sensitivity. And even if it wasn't built for comets, it still became part of the attention machine. We built listening programs that can check, what if it's artificial? In a way that doesn't involve guesswork. They listened. So when people say the final transmission warned the world, the most honest translation is this. The last clean data didn't tell us that someone is coming. It told us that something can arrive from outside, cross our neighborhood fast, and force the entire planet to react in real time. That's the warning, not invasion, exposure. Now, the story reaches its peak at the point that feels most unfair, the goodbye. Because the most important things about 3I, Atlas, were always time limited. The best observing geometry doesn't last. The brightness peak doesn't last. The tail and coma evolve. Then the object dims and slips into a part of the sky where it becomes harder to separate from background. And that's why the final window felt heavy. It wasn't drama, it was physics. It was the slow shutting of a door. And as that door was closing, one question got sharper than everything else. Why did it take until now for us to see 3? If interstellar visitors are truly rare, then we got lucky 3 times in a short span. If they're not rare, then we've been missing them for most of human history. And if we've been missing them, then the solar system has been a kind of open coastline for billions of years, objects washing in and washing out, while we stood there with no flashlight, no radar, no clue. That's where the big chill lives, and you don't need aliens for it. Now layer in the next piece, the one that makes the whole thing feel like it's accelerating. The Vera C. Rubin Observatory. Rubin is built to scan the sky over and over, turning the universe into a time-lapse. And time-lapse changes everything. It doesn't just find objects, it catches them early. It catches the start of the story, not the ending. So 3I Atlas may end up being remembered as the last interstellar visitor that still felt like a shocking surprise. Not because it was the strangest, because it arrived right before the era where we stop being surprised so often. That's a strange kind of warning too. The warning that the mystery phase is ending and the measurement phase is beginning. And if you're someone who likes the scary idea that it's watching us, here's the calm reality that should actually stick with you longer. Whether 3I Atlas was watching or not, we are becoming easier to detect. Our planet leaks radio. Our radar is bright. Our satellites sparkle. Our night side glows. You don't need to imagine a probe that watches Earth. You only need to accept that. If a civilization out there has instruments better than ours, Earth is not invisible. It probably hasn't been invisible for a while. That's not panic. That's just what happens when you scale up time and technology. So what do we do with all this? We do the sensible thing. We stop treating interstellar objects like ghosts, and we start treating them like samples. A sample from another star system is priceless, even if it's just ice and dust. It tells you what chemistry looks like elsewhere. It tells you what planetary systems throw away. It tells you how common these visitors might be. And the best part is, we're not stuck with remote watching forever. The real turning point, the one that will make every final transmission headline look small, is the first true intercept mission. The first time we spot an interstellar object early enough to send something to meet it, not years after discovery. Immediately. Fast. And if that sounds impossible, remember how quickly space science changes when it wants something badly enough. We went from grainy exoplanet guesses to atmospheric chemistry conversations in a shockingly short time. We went from black holes are math to here's a shadow image with the Event Horizon Telescope. These leaps happen, so the ending of the 3I Atlas story isn't a cliffhanger about aliens. It's a cliffhanger about us. Are we gonna keep building better eyes, better listening, better tracking? Or are we gonna keep turning every rare object into a horror story and missing the real lesson? Here's the final truth, in simple words. 3I Atlas didn't warn the world because it talked. It warned the world because it showed up fast and uninvited from outside our system and proved, again, that the universe can reach into our neighborhood whenever it wants. And the final transmission wasn't a message. It was the last clean slice of reality we could measure before distance took it away. That's what makes it feel heavy, because the universe doesn't owe us a second look. If you want to keep going, click the next video on screen, because I'm breaking down what an interstellar intercept mission would actually look like, and the one measurement that would instantly separate normal comet from something truly weird.